Hello, everyone. Welcome to my channel. We're going to do this live stream. Happy Wednesday. We're going to do this live stream. Happy Wednesday. Why is this? That was weird. Okay, so I had some kind of weird relay. I don't know. Every day is an adventure. All right, so what I'm doing tonight is I'm going to go through this process again. Just one more time. I want to practice these systems with 3 variable using the inverse method, and I'm using a specific method for finding the inverse. It's using the matrix of minors and cofactors and finding the adjoint. And yeah, so I hope everyone's doing well. And yeah, I'm going to go ahead and get into it and see how it goes. And if you're here watching me, welcome in, and I appreciate you being here. So we'll go ahead and get this going. The problem I picked out, I literally just picked it out, so I have not spent any time working on it. And I want to just practice this method straight through and see if I can do it without any hiccups. So. Wednesday is a perfect day to do some math. Probably should get this board erased before I go live, but all right. Okay. So go ahead and find the system I picked. I think it was B. Yeah, this is the last one in my book for this section that involve 3x3s. So that are actually, the solution is listed in the back. So it's really important for me to have the answer at least. That way I can work through it if I make a mistake. So I picked this one out. -3x minus 6y minus 15z equal -3. Try this again. We have 2x plus 3y plus 9z, and this is equaling 1. We got -4x minus 7y minus 17z, and that equals -4. And we'll just double check real quick to make sure we have them all written correctly. So my coefficients, we have -3, -6, -15, 2, 3, 9, -4, -7, -17, and -4. All right. And while I dig through all those markers, let's just get a brush one. I'll try really hard not to unplug this cord so the lights come out on me again. All right. Okay. So we have this system. And if I want to use matrices to solve this, then what I'm doing is I'm going to call a matrix, and we'll just name it A. So if we have a matrix A, and this is A sub column 1, well, it's row 1, column 1, and then this one would be row 1, column 2, and then A, and then ... And then this one would be row 2, column 1. This one is row 2, column 2, and then this one will be ... So, and then we have this matrix. So if I want to solve using the formula. So we have this going on. So we have the matrix A times your variables x, y, z, and that's going to equal your constant matrix A, B, C. So if I want to solve this matrix for x, then what I can do is I can say this. I can say x, y, z equals A inverse times the constants. All right. So this method is what I'm doing today. And so I'm going to erase this because I don't want it to be in my way. But essentially, this is what we're doing. I keep in mind the method. All right. So the very first thing I'm going to do is I'm going to split up my matrices that way. So I'm going to start by listing my coefficients. We've got -3, -6, -15, 2, 3, 9, -4, -7, -17. Perfect. I'm going to try and make it a little bit smaller today. And then I'm going to multiply that by my matrix of my variables, x, y, z. And it's going to equal my constants, just the constants. So we've got -3, 1, -4. Right. And as always, I forgot to remind you, if you're watching, you want to post a problem in the chat, see you work it, you're welcome to do it. All right, so the very first thing I have to do is I have to determine whether this matrix has an inverse. And that's why it's called determinant, because it tells you things about the matrix, whether it's invertible or not. All right. So how I calculate the determinant of a 3 by 3 is this way. So you list out your coefficients, just like I did before. Something very satisfying about writing numbers on this board. I enjoy it. So we got -4, -7, -17. And then I'm just going to list the first two columns again. So we've got -3, 2, -4, -6, 3, -7. And then I'll be very careful because I have to go into the diagonals. And so it's we're going to do this diagonal, and the forward slashes are helping me to, if I'm going forward, it's a positive direction. So I'm going to plus the forwards and then subtract the backslashes. So I've got -3 times 3 times 9 plus this column, -6 times 9 times -4. And if this goes smoothly today, what I'm going to do is I'm going to attempt a 4 by 4 next. So we'll see how that goes. So that's plus -15 times 2 times -7. And what we're doing here is we're just using the parentheses to keep track of the order of operations, just to make sure that the math is neat and clean and pretty. So it helps you to stay organized because you're going through the steps, and it helps you to not make mistakes. And if you're like me, you're going to make the mistake, no matter how perfect you get the steps. So we've got -15 times 3 times -4. And then that's minus, so I got -3, okay. Wait, I'm already messing it up. No, I'm not. 15, 3, -4. All right. This one, let's minus this grouping, -7 times 9 times -3. And then one more grouping, minus this diagonal. So that is a -17 times 2 times, and I believe that is a -6. Yeah. Okay. All right, so let's simplify this. So this is 3 times 3 is 9. So this is 9 times 9, and it's a negative. So that is going to be -81. And then we have, let's see, 36 times 6. I don't have that in my head. I bought a book, so it's How to Calculate Quickly, and I didn't make it very far in that book. But if I ever get a rainy day, I'll get the book back out and start doing this. It's a way to train your mind to do multiple calculations in your head, and it's amazing what your mind is, what the human brain is capable of. It's just shocking me sometimes when I see the amazement. So we've got plus 216. 2 negatives make a positive. So, and then we've got plus 15 times 2 is 30 times 7. Let's see. 3 times 7 is 21. So is that 210? Let's go ahead and do it in the calculator just in case. Perfect. 210. 2 negatives make a positive. So we're good there. Positive 210. So we're going to the next one. 15 times 3. That's 45 times 4. Sometimes I do a lot better math when I'm not nervous. And you know, it's when you're being videotaped, you can inevitably, it's just a psychological thing, I think, that I gotta get through. So 2 negatives make a positive here, and then another negative is going to bring me back negative. So this is a -180. And so we got this one. So this is 7 times 3, 21 times 9. And I'm getting 189. So we got 2 negatives make a positive, another negative. We're going to go negative here, -189. And then we've got this one, 17, 2, and 6. And I'm getting 204. Again, 2 negatives make a positive, another negative. We're going to go negative. And it's just really good practice for me. And when I'm explaining, if I can just calm down and breathe, then what it does is it helps me to just process the math. So what I like to do when I have a string of these right here is I like to add all of the like signs first, because it just makes it easier. So I'm going to say 81 plus 180 plus 189 plus 204, and I've got 654, and that I know that it's negative. I'm just adding all of the negatives first. So then we have 2 positive numbers, and I know that that is plus 400 and looks like 26. 426. So whatever this equals is going to be my determinant. And it's definitely not 0, so that's good. And so we got 654 minus 426, and I'm getting 228. And it's negative because when the signs are different, what you're going to do is you're going to subtract and you keep the sign of the larger absolute value. And there's no way it's that big. Is that possible? Well, all right. So we've got, I know my calculator will calculate the determinant also. And there's just, all right, so we're just going to box that because I need to erase the work. Oh, I wish sometimes I had someone else up here helping me just to double check it's the multiplication, add, subtract, multiply, and divide. That's where the mistake gets made most often. So, all right. Yeah, it looks like it's probably right. It's just a really large determinant. So we'll just go with it. And the next step. So now we have to calculate the matrix of minors. And you do that by this special process here. And I'm going to move the determinant over here. We've got D equal negative 228. I have a hard time believing that's right, but we're just going to go with it. Give us some really big numbers. I also want to go ahead and state the, before we do the matrix of minors, let's go ahead and list the solutions. Okay. So this one was 12. Which one was it? We did where's the problem that I picked? Okay, it's B. Sorry. It's B. All right. So, fractions, that's why I picked it. All right. So our solution is 12B, come on, 1/2, comma, 3/2, comma, negative 1/2. Okay. All right, so let's go ahead and do the matrix of minors now. Erase that just to kind of get some room here. All right. So we're going to go ahead and draw this out. This is kind of a lot of work, but I like it. Something satisfying about just working through the math on this big board. And I feel like every time I do a live stream, I get a little bit better. I just want it to be natural. And I would just rather be transparent and be myself up here, but we're not there yet. All right, so what we're doing is we are taking each position has a location in this array. They're called matrices. And so what I'm doing is I'm going to find this position first. So I'm going to this number right here. And I'm crossing out the row and the column that that number exists in. And there's a resulting 2x2 matrix in there. And so that's what I'm going to list. 3, 9, -7, -17. So we'll do this position next, crossing out the column and the row. 2, 9, -4, -17. Okay, now this column here, or this position here, and so I've got 2, 3, -4, -7. We'll do this one next. And visual, so I like to see it. -6, -15, -7, and -17. All right, this one next. The middle one's my favorite for some reason. I like it. It's just the 4 corners. So -3, -15, -4, -17. This one next. Okay, -3, -6, -4, -7. And it's important to have certain checks in place. So when I finished finding these submatrix, the minor matrix, I will go back and make sure and I don't have any duplicates. So -6, -15, 3, and 9. We got -3, -15. -3, okay, 4, -4 and -17. And then one more to find. We have this one. It's -3, -6, 2, and 3. All right. So after we found this, we're going to calculate sub-determinants. So each one of these has a determinant, and it's the same method where you go through the diagonals. The forward diagonal gets plussed and will be a positive, and then the back diagonal will be a negative. So it's the same exact method. It just doesn't look as complicated because it's a 2 by 2, not a 3 by 3. All right. So we can just go ahead and list them down here. So for that first one, I have 3 times -17 minus -7 times 9. And again, I'm using these parentheses to keep track of my order of operations. It just helps everything stay organized, and it helps you to, you're taking care of your brain, because brains, they're funny. Like, they like to have the information organized and orderly. We do not like, as human beings, we do not like disorder, and we do not like chaos. Chaos in the sense of like the modern term. All right, so 17 times 3, I'm getting a 51, and it's negative. And then 7 times 9, well, I know that is 63. Negative, 2 negatives, it's going to make it positive. So that's a plus 63. And so we have 63 minus 51. It's looking like maybe 12, positive 12, but seeing is believing. So I have to have the confirmation on the calculator. So we'll go ahead and circle these for now, and then we'll go ahead and build our matrix of minors. All right. So let's go ahead and list them so that we're not having to figure out which one's which. So what we're doing is we're building a matrix of the determinants. That's exactly what we're doing. So this is 12, and we'll do this position next. And just making sure that we're real careful about where they're going in this matrix, because it's very specific. If it's this determinant, it has to go in this location. This location's name is row 1, column 1. All right. So we're doing 2 times -17 minus -4 times 9. And now that you can't see what I'm writing, so I need to move. So we got 17 times 2, and I think that's 34. And negative 34. And then we've got 36, which is negative, and then it becomes positive. So that's plus 36. So it looks like that determinant is positive 2. So we can go ahead and list it here. Let's do this one next. So we've got 2 times -7. And that's minus -4 times 3. So it looks like -14, -12, negative makes it positive, so that's plus 12. It looks like -2 on that one. And then this one next. So we've got -6 times -17 minus -7 times -15. All right, so 17 times 6, I'm going to say it's 68, but let's go ahead and double check it. No, 102. I was way wrong. Okay, that's all right. We got positive 102, which I should have known better because 5/20 is 100. So silly me. 7 times 15 is 105. So two negatives make a positive, and then another negative makes it negative again. 105. So this determinant looks like 1. We'll do this one next. So we've got -3 times -17 minus -4 times -15. Right, and I know that's 60. 15 times 4, 60. All right, 17 times 3 again. It's 51. I'm just trying to be extra cautious because I really don't want to make a mistake, but inevitably it might happen. So, all right, two negatives make a positive. Another negative is going to go negative for us. So we've got -60 and 51. That's -9. All right, good. Okay, so now we have this one. -3 times -7 is 21. So wait, -3 times -7 plus, minus -4 times -4. So we've got 21 positive, 16 positive, and then the negative is going to bring it back negative. Was that 5? All right, so we got 9. Let's see, -6 times 9 minus 3 times -15. So 9 times 6 is 54, -54. 3 times 15 is 45. Negative goes back to positive. And is that 9 again? -9? We'll double check it. -9. And then we've got 2 more. Look, I didn't even think of that thing. Okay. So this one next, -3 times -17 minus -4 times -15. So we've got plus 51. We got plus 51. And then minus 60, it looks like. 2 negatives make a positive, and we're going to go back negative, -60. All right, perfect. So that is going to be a -9 again. Lots of 9s here. All right. One more. -3 times 3. We'll sneak it in here. And that is minus 2 times -6. So we've got -3 times 3 is -9. 6 times 2 is 12. Negative, and then it's going to be positive. And that looks like +3. Oh, all right, good. So here's our matrix of minors. And I'm going to have to erase that scratch. All right. So the next thing that we're going to do for the method, all right, so we have to apply this rule of cofactors. And we might practice that tomorrow, and I'll show you the formula from my book. But for now, it's just alternating, and it starts with a plus. So I've kind of just memorized the pattern so that I can write it out quickly for my students. But if you want to know how these are found, then I'll show you sometime. It's kind of lengthy. Plus, minus, plus, minus, plus, minus, plus, minus, plus. All right. And so this is the cofactors. And what we're doing is we're multiplying each one of these entries by a 1, either a +1 or a -1. So that we're going to restate this matrix using the cofactors. All right, so 12 is going to stay positive. 2 is going to become negative. This one's going to stay negative. This one is going to become negative. Negative 9 will stay negative. 5 becomes negative. Negative 9 will stay negative. 2 negatives make a positive, so that one's going to go positive, and then this one will stay positive. Perfect. So this is the cofactors. These are the minors. These are the cofactors. And then what we have to do now, we have to transpose. So we transpose by taking this matrix here. We're going to keep the diagonal. 12, negative 9, 3. And then we're just going to swap out along the diagonal. So we got negative 2, negative 1, negative 9, negative 2, 9, and negative 5. Perfect. So after we transpose, am I missing a step? All right. Now I believe all I have to do is take this matrix and multiply it by my determinant. Okay. We're going to go ahead and list this formula. So to calculate the inverse matrix, A inverse of 1, that equals A oh, I missed that. Oh, yeah. Scratch that. It's 1 over the determinant times the adjoint. Right. So this is the adjoint. That is the adjoint matrix right there. So we figured that out. We figured the determinant out. Now to calculate A inverse, we just simply have to multiply by 1 over the determinant. So if my determinant is negative 228, then 1 over the determinant is going to equal 1 over negative 228. And then that's going to be times that matrix, the adjoint matrix, which is 12, negative 1, negative 2, negative 2, negative 9, negative 5. And this one's negative 9, positive 9, and 3. And just make sure I got my lists. 12, okay, it looks good. So each one of these values, these numbers in these locations in the matrix are going to get quantified by this number. So if it's 1 over, they're going to get smaller. So these are going to be small. So let's go ahead and do that here. We'll list it here. I was trying to learn to manage my space in my board and be a little bit more organized. So let's see if we can reduce this down. We can do some work and I'll just erase it later. So this first location is giving me negative 12 over 228. When I multiply 12 times 1 over 228. So let's see what that reduces down to. I hope it reduces. Yes, it's 1 over 19. So this first location is negative 1 over 19. Okay, because this reduces down. And so let's go ahead and write the next one. This is 1 over 128. It's going to stay the same. 2 negatives make it positive though. So this is going to be positive 1, 228. And then this one, 2 over 228. So half of 228 is 114. 2 negatives make a positive. So I'm saying, so that's positive 1 over 114. That this position again is also a positive 1 over 114. 9, does 9 divide 228? Let's see. Yeah, I hope it does. It does not. See if it at least divides 3. Okay, so we can divide out a 3 from there. It's gonna be 76. So 9, let's just show it. 9 over 228. That's 3 times 3 divided by 76 times 3. So the 3's will cancel. So you're left with 3 over 1, just 76. 3 over 76 for that middle term. And this position here, 5 obviously doesn't divide 228, so 2 negatives will make a positive, so they'll go positive. 5 over 228. The bottom row, 9, we figured that out, that was 3 over 76. 2 negatives make a positive. And then this one is going to be negative, so it's just a negative 3 over 76. And then one more. We know that 3 goes into 228. This is going to be negative 1 over 76, I believe. Yeah. All right. So let's go with it. This, if we calculated correctly, which I'm really hoping we did, this is my A inverse. So now, according to the formula that I erased it. I should be able to state that XYZ equals my inverse times my constants. So I'm just going to put my constants up here and do just a simple matrix multiplication. So -3, 1, -4. And so now I'm taking this row and multiplying it by this column. This is a 3 by 3 times a 3 by 1. So the resulting matrix is going to be a 3 by 1. So we'll just go ahead and do this here. So if I take this entire row and I multiply it by this column, I'm taking this position times this position times this position, and this position times this position. All right, and this is what you get. So we get -1 over 19 times -3 plus 1 over 228 times 1 plus, it looks like 1/4 over 114 times -4. And so we've got 3 over 19 positive. And this one is just going to be plus 1 over 228. And then this one is going to go negative on me. -4 over 114, which I don't think, let's see. Okay, it doesn't. It goes into 2 though. All right, so let's go ahead and get a common denominator. All right, and it's going to be 228. So this first one, 19 times 12 is 228. So 3 times 12 is 36. So this one is 36. This is just plus 1. And then 114 is 2. So that's going to be 4 times 2 is -8. I'm just adding these fractions really quickly. So 36 plus 1 is 37 minus 8 That looks like it's time. Come on, let's just do it. All right. 36 plus 1, 37 minus 8, 29. Okay, so I'm getting here for this first position, I'm getting 29 over 228. And maybe I made a mistake. I don't know. Let's see. It doesn't reduce down. 29, let's see. Is 29 prime? Yeah, this is not correct because we have our solution. All right, so let's go ahead and just play it out. So we're going to do this column right here and times, or this row times this column. All right. So I'm losing confidence because I realized that I made a minor arithmetic error and I'm not going to get the right answer this time. So we'll see if we get y and z though. So we've got 114 times -3 plus 3 over 76 times 1 plus 5 over 228 times -4. And if anybody watching sees this mistake and they want to come call me out, please, by all means, please do it. I want to get the right answer. Okay, so this is going to be -3 over 114. And then this is plus 3 over 76. Usually it's something really minor, like a minor arithmetic error. Majority of the time, that's what the case is. So, so this is going to be -20 over 228. All right, so we'll add our negatives. Let's just get a common denominator. We know it's 228. So see, that's 2, so that's going to be a -6. 76 times 3, so that's going to be a +9. And then 228, that's going to be -20. And then, so we've got -26 plus 9. Is that 15? -15? It's okay. Oh, 17, my fault. Oh, good. So this one divides, 17 divides 228. That's good. So we can reduce this one down. No, it doesn't. Oh, all right. So this one is also not correct. I don't think it is because 17 is prime and it doesn't divide 228. All right, so one more. Let's go ahead and go through the method. We're not going to get the right answer today, unfortunately. So we've got 3 times 76, or sorry, 3 over 76 times -3. Oh, that is going to be 9 over 76. And it's a negative. And we've got -3 over 76 times 1, so that's just going to say -3 over 76. And then 1 over 76 times 4, negative, is going to be +4 over 76. And I like that better because we already have our common denominator. It makes it a lot easier. So when you're adding fractions, 76, and then we've got 9 and 3 is 12, -4 is 8, so it's -8. Does that divide? I don't think it does. Okay. Oh, we might have actually got Z. Hang on. So let's go ahead and split this fraction up. See if we can reduce it down. So we have 2 times 2 times 2 times, yeah, 3 times, and then 76. Oh, unfortunately, I don't think it's going to be the case. So 2 times 2 times 19. So we got this. So we got 2 over 19 for Z. So I've got a lot of things circled here. So this would be X. This would be Y. And this would be Z. And just to see how close I am, let's go ahead and divide 17 by 228. And that is 0.7, not 1/2. So pretty off on that one. And then this one should be an improper fraction. Why? So I'm gonna really figure out what I did wrong. Okay. Well, I won't be doing the 4x4 tomorrow. I'm gonna probably just table this problem. I'm gonna go ahead and put the inverse. We're gonna go ahead and put it in the calculator. Let's go ahead and do it. We can do that right now real quick. It won't take me very long. So what I'm gonna do is, and I wish that YouTube had a feature where I could change the and put my document camera, because I could show everyone how to do this. It's very, very easy to do. But let me just go ahead and put this matrix in here real quick, and it won't take me very long. We're just going to go ahead and it's a 3 by 3. So we're going to say -3, 6, -15, +2, +3, +9. All right. All right. I forgot to tell it math. I want a fraction form, so call A inverse. We'll go into math 1. All right. So here is the actual inverse. I was way off. So I did some funny math in here. So the actual inverse, let's sneak it in here somewhere. Right here next to it. Okay. It should be 2, 1/2, -3 over 2, -1/3. It's all these fractions. -3 halves, -1/3, 1/2. -1/2 and +1/2. All right, so we know that this is the actual A inverse. That'll save me from having to do it later. One of the beautiful things about making a mistake like this on my part, is that it really motivates me. It bugs me. So I'm more inclined to go and spend time in my spare time. I've allotted this time for math every day. And so I really haven't been, because I'm so busy and like I don't really have a whole lot of time to do the math. So I've kind of allotted it to doing it in front of the camera. And yeah, so that's one of the anyway, I feel like that's the silver lining, because now it's lighting a candle for me to go and figure out my mistake, because I gotta find it. But yeah, this is the actual inverse. I'm going to circle it so that whenever I come back in here tomorrow, I'll try to come in before my live stream. Just depends on how the day goes, But we're almost 50 minutes in, so we better stop there. I don't see any problems for students asking me questions, so I'll just go ahead and stop there. And thank you for watching my video. And I look forward to seeing you next time. And yeah, I'll just sign off. I'll say bye for now.